Samples and population are really important when you're talking about statistics. Okay, so the population is the entire group of people or objects you are looking at. The sample is the part of that population that you use in your experiment. You can use your sample to make conclusions about your experiment, make inference. We talked about this word inference. Inferences about your population. Basically, you need to identify your population, select a sample, then interpret the data of that sample, and then make an inference about that population using that data from the sample. We need to make sure that they are unbiased. Unbiased samples are representative of the entire population. So it's they're usually selected at random, they should be selected at random, and it's large enough to provide accurate data for the group. If you are looking at a group of 100 people, a handful, even 10 might be a good sample. But if you're looking at like the population of the United States, you're going to be looking at a lot bigger numbers for your sample. So you need to look at your population and see how big your sample should be according to your population. A biased sample is not representative of the entire population. One or more parts of the population are favored over another. Okay, so unbiased samples are really good to use for predicting what would happen in the entire population. Biased samples are not a good way to represent what would happen in the entire population. It's just not valid. Okay, so we want to estimate the number of students in a high school who ride the bus. Which one is unbiased? 4 students in the hallway. We have 800 students here at school. 4 students is not going to be a big enough sample to get a sample for the entire school. All students in the marching band. That is a really good example of maybe students in the arts program, but it really isn't even students in the arts program because they're only coming from the band, they're only coming from one group, so it's not a good sample. 50 seniors at random. In a high school, seniors usually don't ride the bus, right? They're old enough to drive, many of them do, so it's not a good sample. It's only seniors and it's not taking into any other levels of learning, any of the other grade levels. 100 students at random during lunch. This is going to be your best one. It's random, okay? It's during lunch, so most of the students will be there. It doesn't mean you have to be in the lunchroom. You could be talking to students who are leaving, but you need to make sure it's random and it represents all of the groups in the school. Okay, so let's talk about this. You want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. You survey the 20 residents who live closest to the new sign. 15 support the sign and 5 do not. So you conclude that 75% of the residents in your town support the new sign. B, you survey 100 residents at random, 40 support the new sign and 60 do not. So you conclude that 40% of the residents of your town support the new sign. This one is actually more accurate. This one is only looking at those people in that neighborhood. Of course they're going to support that sign more than this group down here. They live there. They want their neighborhood to be safer. They have problems getting out of their neighborhood sometimes maybe, so they want a stop sign there so that they can get out of their neighborhood. These people maybe never go in that neighborhood and they don't want a stop sign stopping them every day as they drive past it. So this is a much more accurate, a much more unbiased sample of your entire town. If you were talking about the neighborhood, this would be a great sample, but you're talking about the entire town, so you need to make it more broad. You ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number N of students in the school who watch 1 movie per week. So this is our 75 students, and 21 out of 75 watch 1 movie per week. So that is the students in our survey that watch 1 movie a week over the total number of students in our survey. And we need to compare that to our total number of students, and we need to solve for the number of students who watch 1 movie a week. So you can use your cross products or you can use equivalent fractions. You've got lots of different strategies to use that you can actually solve for the number of students in school, the prediction of the number of students in school that watch one movie per week. And that is what you need to know about samples and populations.